example of 3 over 4 plus 1 over 3. So if you remember back when you learned fractions, multiplying and dividing fractions was a little bit easier than adding and subtracting, because in adding and subtracting, when you're doing fractions, you need a common denominator. Okay? So that's what makes adding and subtracting rational expressions a little bit different, okay? But we're going to look at this simple example with these fractions first. So 3 over 4 plus 1 over 3. We have denominators of 4 and 3. So how do we find a common denominator? So a common denominator, if you think about it, 4 and 3, what's a number that both 4 and 3 can fit into evenly? And so the common denominator there is 12, okay? So an easy way you could do that is actually just multiplying the two together. But I'm going to show you a process in a few slides for how to find that lowest common denominator pretty quickly, okay? So 4 times 3 is 12, so I'm going to rewrite my fractions both with a denominator of 12. So if I look at my original question, 3 over 4, I've now turned 3 over 4 into a fraction with a denominator of 12. So how did I get from 4 to 12? I had to multiply that by 3, right? So whatever I do to the bottom, you have to do to the top as well. So I also have to multiply the top by 3, okay? So over here, for 1 over 3, for that fraction, I now have a denominator of 12. What did I do to the 3 to get 12? I had to multiply by 4, right? But whatever you do to the bottom, you have to do to the top as well. Okay, so now that gives us our new numerators. So 3 times 3 at the top gives us 9, and 1 times 4 gives us 4. Okay, so now I can properly add these two fractions because I have a common denominator of 12, and I can just add right across, which is 13 over 12, not over 24. Don't add those denominators, okay? It's just over the same denominator, okay? So we're going to use that idea to now do this with rational expressions, okay? So 2a over b plus 3b over a. This is very similar to what we just saw with the denominators of 3 and 4. What did I do to get a common denominator? I multiplied them. So that's exactly what we can do here. Okay, so a common denominator, which is what I'm just going to say CD is, common denominator, in this case would be just A times B. Okay, so now I'm going to rewrite my expressions here with a common denominator of AB. Okay, just like we did before. Instead of our fractions being over 3 and 4, I had fractions over 12 instead. Okay, so going back. So now that I have these two fractions over AB, I have to look at how they're different from the original. So if you look at the first one here, 2a over b, the b now became an ab at the bottom with the denominator. So what changed? It got multiplied by a. So I'm going to multiply the a, but I also multiply the top. So a gets multiplied at the top. And then if you look at the second one, 3b over a, in order for a to get a common denominator of ab, I had to multiply that denominator by b. So also the top by b. Okay? So 2a times a, that's 2a squared. And 3b times b is 3b squared. Okay? So in the end, we can just add right across. Now, I'm going to give a little bit of warning here. You do not want to start slashing here, okay? Don't slash. Otherwise, you're going to just get right back to where you started, right? The idea here is to get the common denominators so that we can add across. Okay, so once we have our common denominators, we're going to have 2a squared plus 3b. I can't add those two together. I can just write it down like that, all over ab. Okay, and that's our final answer. And if we were to look at our restrictions, okay, if we look at our denominator here, I have a count on equal to 0, right? Because if a was 0, ab would all be 0, and the whole denominator would be 0. And b also cannot equal 0. Okay, basically if you have monomials like that, the restrictions are just going to be 0 for the variables. Okay, so let's go to another one. Okay, so x plus 1 over 3 minus x minus 1 over 4. So we've already seen this idea about 3 and 4 being our denominators. So we already saw that we have a common denominator of 12. So I can just rewrite these two fractions with denominators of 12. And notice I put a subtraction because that's what we're doing. And so if we look at the difference, the first fraction, in order to get from 3 to 12, I have to multiply by 4. Okay? So I have to multiply the top by 4. And notice I have to actually multiply the whole of x plus 1 by 4, not just x. Okay? So the same thing happens with the other one. So x minus 1 over 4. How do I get from 4 to 12? Well, I have to multiply that by 3. So I'm going to multiply that by 3 here. Same thing, I'm going to multiply x minus 1 by 3. So I'm going to write what just happened there. So we're going to have 4 times x plus 1 on the top here. And we're going to have 3 times x minus 1 there. Okay? Now we do the multiplication out. So 4 times x, 4 times 1, which is 4x plus 4 over 12. Okay? And I'm going to get you to be really careful here. Don't forget this is a negative 3 that's being distributed here. Okay? So this is a minus 3x, and then it's a plus 3. That's all over 12. Okay? So we can now just combine across the top. So we have 4x minus 3x, which is x, and we have 4 plus 3, which is 7. Okay, so it's x plus 7 over 12. Are there any restrictions? Well, if we look at our denominators, they're just 3 and 4. Is there any way those could be 0? No. Okay, so we don't have any variables there, so we don't have any restrictions. No restrictions. Okay. All right. Let's now go to this example. Okay. So look, we have two completely different denominators, x minus 2 and x minus 1. It's the same idea. In order to get a common denominator, we can just multiply the two together. So it's going to be x minus 2 times x minus 1 as a common denominator. Okay? Same thing we were doing before. So I'm going to rewrite x minus 2, x minus 1, okay, minus, same thing, x minus 2, x minus 1. Now, how did the first fraction, how did the denominator in the first fraction change? I have x minus 2 for the first fraction, and then my common denominator has an x minus 1. So I had to multiply by x minus 1. So I have to also multiply the top by x minus 1. Okay? Same thing for the other one. 2 over x minus 1. How is the denominator, the common denominator, any different? Well, x minus 1, the difference is it needs to be multiplied by x minus 2. So I have to also multiply the top by x minus 2. Okay? So let's go ahead and do that. So we have x times x minus 1 on the top for the first one, and 2 times x minus 2 on the top for that one. Okay? So let's now do the distribution. Okay? And because we're just combining it, because they have common denominators, I'm going to put it all over the same denominator. Okay? It's a lot easier to just write it once than twice at this point, because we already have common denominators. So x times x minus 1, x squared minus x. Negative 2x times x is negative 2x. And again, don't forget about this negative 2. I guarantee you some of you are going to make this mistake, okay? Negative 2 times negative 2 is plus 4, okay? Watch out for that. So in the end, we get, combine the top, x squared, combine our like terms, we have negative 3x and plus 4, all over x minus 2, x minus 1, okay? And that's it. So our restrictions here are x cannot equal 2 and x cannot equal 1, and that's coming from here, okay? All right, let's go to another one. Let's add these two fractions. Now, if we were to look for a common denominator here, we could easily go 12 times 3 to get a common denominator of 36, but there's a lower common denominator, and if you can see it, if I can just multiply the bottom here by 4, do you agree that I'm going to have the same denominator of 12? So here's a situation where you don't need to actually multiply both of the fractions. You can sometimes multiply just one of the fractions in order to get common denominators. Okay? So this just becomes 7 over 12, didn't touch that, plus I multiplied the bottom 3 by 4 to get 12, and the top has to get multiplied by 4 as well, so that ends up being 4, and I get 11 over 12. And that's it. Okay, so we're going to use the same idea for our rational expressions. So let's have a look at this one here. 7 over 4x minus 3 over 2x. Does 2x fit into 4x? Okay, is there any way I can just multiply that by anything to get the same common denominator, and that would be 2. If I multiply that second denominator by 2, I'll get the same common denominator of 4x. So I have to also multiply the top by 2, and we get 7 over 4x minus, same thing over 4x, and 3 times 2 is 6. So now I can subtract. 7 minus 6 is just 1 over 4x. And I have a restriction here. X cannot equal 0. Okay? Because 4 times 0, that would make that all go to 0. All right. Okay, let's do another one. If you look here, x minus 2 over x squared minus 1. That should bring some light bulbs here. This is a difference of squares. Okay, everything else should be okay. So 2x plus 1, x plus 1, that's fine. So now let's do a little bit of factoring. So this is the same thing as x minus 2 over x squared minus 1 factors to x plus 1, x minus 1, plus 2x plus 1 over x plus 1. Now have a look at the denominators. Look at this denominator and look at this denominator. This is very similar to what we just had with, we go back to 12 and 3, right? I only had to multiply the 3 by 4 to get 12. So same thing here, if you look at the denominators here, I only need to multiply this second fraction by what's missing in the first one is x minus 1. Okay? Can you see that? That they now have common denominators. I didn't have to touch the first one. The only thing that was missing in the second one was the x minus 1. So I multiplied top and bottom by x minus 1. So now, if I were to rewrite my fractions, first one is okay. X plus 1, x minus 1, plus, now watch out for this. This is all getting multiplied by x minus 1, so I have to put that in brackets. That whole top numerator is getting multiplied by x minus 1. So x plus 1, x minus 1 is our denominator. So now we just have to simplify the top. If we look here, we have a binomial times a binomial. Yep, we need to FOIL. Okay, so let's go ahead and do that, and I'm going to put everything over my common denominator. x plus 1, x minus 1. So x minus 2 is fine. We'll leave that. Now let's FOIL. 2x times x, 2x squared. 2x times negative 1 is negative 2x. 1 times x is plus x. And 1 times negative 1 is negative 1. Okay? And now we can just collect our like terms. We have a 2x squared. We have negative 2x plus x plus another x, which actually just cancels out. And then we have negative 2 and negative 1, which is negative 3 over x plus 1, x minus 1. Okay, and that's our final answer. So our restrictions, we have x cannot equal 2. We either have a negative 1 or a positive 1 from the denominators. Okay, so let's keep doing some examples. Let's look at the next one. Okay, 4 over 9 plus 5 over 12. This one's a little bit different because now we want to find a common denominator, but 9 times 12 in this case doesn't actually give us the lowest common denominator, okay? Keyword being lowest there. Okay, there's actually another way we can figure out what our lowest common denominator is. Now, if you were to just look at those and think about it, if you were to just think about the lowest number that both of those numbers will fit into, it's going to be 36, okay? And some of you may have gotten that already. Some of you may have struggled with figuring out that. So I'm going to show you a way to find out your lowest common denominators pretty quickly, okay? So what we're going to do is we're going to figure out, okay, what's the lowest common denominator of 9 and 12? So first, what we're going to do is we're going to list out the factors of 9, okay? 9 is 3 times 3, right? 12 factors are 3 times 4, right? We could go and turn them into primes, but we don't really need to in this case. What we see here is that they have a common factor of 3, okay? So that's all they have in common. So when we find our lowest common denominator, what we do is we just take one of these 3's from this common group. So I'm going to write a 3 from our common group, and then we just tack on any other leftover factors. In this case, 3 and 4. We're going to do some other examples soon, just so that you get the hang of it, but it's going to be 3 times another 3 times 4, which, if you multiply that, 3 times 3 is 9, times 4 is 36, which is the exact same as what we figured before. Okay, let me do another example. Let's find the LCD of 18 and 20. Okay, what's the lowest common denominator of 18 and 20? Well, let's write the factors of 18, 9 and 2. Let's write the factorization of 20. That's 2 times 10, right? Look, they have a common factor of 2. All right, so I can just write the LCD as one of those from that common group and anything else left over, which is a 9 and a 10. So that's 18 times 10, which is 180. Okay, so that's our lowest common denominator, 180. Okay, let me do another example. What's the lowest common denominator of 16 and 24? Okay, 16, let's factor it out. 4 times 4. 24 can be 6 times 4. Okay, and I see here that there's a common group of 4. But what I'm also seeing is that there are going to be some common factors in here as well, right? So let me just keep going here. Let me keep going and say that that's the same thing as 2 times 2 times 4, and this is 2 times 3 times 4. Okay, so this I've already established they were the same, right? But you see here I also have a common factor of 2. Okay, so if we take one group from one of the factors from each of these common groups, so I'm going to put one of the 2's, one of the 4's, and then anything left over, which is 2 and 3. So my lowest common denominator, if we multiply them all together, is 2 times 4 is 8, times 2 times 3 is 6, so that's 48. Okay, let's do one more. Lowest common denominator of, let's say, 10 and 25. Okay, so 10, we've got 2 times 5, and 25, we've got 5 times 5. Right? We have common factors of 5. So my lowest common denominator, take 1 from that group, which is 5, put on everything else. 2 into 5, you get 10 times 5, which is 50. Okay, so 50 is your lowest common denominator. Okay, so now how can we use this to help us with rational expressions? So let's look at this. Y over 4x equals 2 over 2xy. Let's figure out our lowest common denominator of 4x and 2xy. Okay? So for 4x, I basically have 2, a 2, and an x. Right? And for 2xy, I have a 2, an x, and a y. So if you look here, I have a common group of 2 there. Nothing. Oh, and I also have a common x. So for my LCD, I take 1 from each group, so 2x, 1 from each group, and tack on everything else, which is a 2 and a y. So in the end, the lowest common denominator is 2 times 2, which is 4xy. Okay, so that's now my lowest common denominator. So I can now subtract these two rational expressions with that lowest common denominator. So let's do this. So y over 4x minus 2 over 2xy equals something over 4xy minus another something over 4xy, which is our new common denominator. So how did I get from 4x to 4xy for the first one? I had to multiply by y. So I multiply the top by y as well. How did I get from 2xy to 4xy? Well, multiply that by 2. Multiply the top by 2, and we end up with y squared minus 4. So in the end, this is y squared minus 4 all over 4xy. That's the final answer. Okay, and the restriction here, coming from the denominator, x cannot equal 0, y cannot equal 0. Okay, over x squared minus 1. So we've got some factoring going on. So here, down here, we have a simple trinomial. And at the bottom here, we have a difference of squares. Okay, so let's do some factoring there to simplify this. So we've got x minus 3 over, let's do the factoring. Let's do some side work. Okay, we need two numbers which add to give me 3 and two numbers which multiply to give me 2. If you think about it, we've got 2 and 1, 2 and 1. So this factors to x plus 2, x plus 1. I'm going to add x minus 2 over difference of squares. X squared minus 1 becomes x plus 1, x minus 1. So now if you have a look, looking at our denominators, we can tell right away what common factors they have now that we've factored them. So if you see, we've got a common factor of x plus 1. So if we now want the lowest common denominator, we're going to put one of those factors, so x plus 1, just one of them because it's common, and then everything else that's not common. So x plus 2, x minus 1. Okay, and that's my lowest common denominator. Okay, x plus 1, x plus 2, x minus 1. So what's different between the first denominator here and this new lowest common denominator? We're missing an x minus 1. So I got to multiply that by x minus 1. Also got to multiply the top by x minus 1. Okay. What are we missing over here? Compared to this one, we're missing an x plus 2. So I need to multiply top and bottom by x plus 2. Don't forget those brackets. So x minus 3 times x minus 1 and x minus 2, x plus 2. So if we're going to actually multiply those out, this guy we're going to need to FOIL. Okay? So this is going to equal, I'm going to just trust that you're okay with the FOILing, and I'm going to write down the simplified answer. So it's going to be x squared minus 4x plus 3. Okay, so that's what's going to happen if you FOIL this out. Okay, you're going to end up with x squared minus 4x plus 3 plus, over here, this is a nice special identity, right? That's kind of like your difference of squares. So it's x squared minus 4. Okay? So this is all over x plus 1, x plus 2, x minus 1. Okay, and this is equal to, we simplify the top, we've got 2x squares. Oops. We're going to have 2x squared minus 4x, and then plus 3 minus 4 is minus 1. All over x plus 1, x plus 2, and x minus 1. And that's the final answer. And if we have restrictions, x cannot equal negative 1, negative 2, or positive 1. All right. Okay, let's go to the next one. Subtract y plus 1 over y squared plus 2y minus y plus 1 over y squared plus 3y. Have some factoring in here. We have GCF down here and another GCF down here. So let's go ahead and do that. Y plus 1 over, pull out a y plus 2, minus y plus 1. Here, pull out another y plus 3. All right. So now we're seeing we have a common factor in our denominators of y. Okay, so because we have a common factor there of y, for our lowest common denominator, we're going to put one of those y's and everything else. So y plus 2, y plus 3. That is our common denominator. Y plus 2, y plus 3. Okay? So how is this denominator different from this one? Well, we're missing a y plus 3. Y plus 3. Okay. How is this one different than our common denominator? We're missing a y plus 2. So multiplying top and bottom by y plus 2. So we get y plus 1 here, y plus 3, and y plus 1, y plus 2. Okay. So we're going to FOIL. Again, I'm going to trust that you're okay with your FOILing. And I'm just going to give you the simplified answer. It's y squared plus 4y plus 3. Okay. Minus some more FOILing here. Now be really careful here. We're subtracting whatever gets FOILed here. So I'm going to make sure that goes into a bracket. Okay, again, really, really careful with this subtraction. Okay, so I'm going to leave this in a bracket first. It's going to be y squared plus 3y plus 2. Okay, all over my common denominator. Y plus 2, y plus 3. Okay, and now we can subtract. Okay, y squared plus 4y plus 3 this subtraction goes into each of those terms. Minus y squared, minus 3y, minus 2. All over our common denominator. Okay. And then we can now simplify. So it's going to be y squares cancel. 4y minus 3y is just y. And then 3 minus 2 is just plus 1. So we have y plus 1 over y plus y times y plus 2, y plus 3. All right, final answer. And our restrictions, y cannot equal, if you look here, that can't be 0. If you look here, can't be negative 2. And here, here, negative 3. All right. Okay, next. So here are your steps to add or subtract rational expressions. So first, identify the types of factoring needed, if applicable, to actually just the denominators. It's not really that important to factor out the numerators because we're going to be multiplying those out and simplifying them later anyways. Okay, so just for the denominators. Then go ahead and factor. Then you want to determine a common denominator, right? For adding and subtracting, always need common denominators. Okay, then once you determine your common denominator, we're going to multiply the numerators to create equivalent rational expressions. I'll just put REs, rational expressions, which are basically like your fractions of your polynomials. Okay, so what I mean by that is that it's the step of when we're taking a look at what's different between the first denominator and your common denominator, and you're going to multiply your numerator by that same factor because you need to multiply the top by whatever you multiplied the bottom by. All right, so multiplying the numerators to create equivalent rational expressions, fractions, with common denominators. Okay. Then we're going to simplify across the top. Okay. So this is when we're doing the FOILing or just the multiplying out. And then add or subtract those expressions across the numerators. Okay. I'm going to remind you to be really careful with the distribution of subtraction. Many students always make this mistake. Subtraction. Okay, so for an example, you have negative 2 times x minus 4. Okay, don't make the mistake of forgetting about that negative. Okay, this is going to be equal to negative 2x plus 8. Okay, so watching out for this step right here. The negative 2 times negative 4 is a positive 8. Okay, and finally, state restrictions for all denominators. Because in adding and subtracting, your restrictions are only coming from your denominators, unlike when you're dividing rational expressions. All right, so I hope you have been able to follow along with me here. If you have any questions, please let me know. But for now, this is it for your notes for adding, subtracting, multiplying, dividing rational expressions. We'll be reviewing this again next week. Okay, but hopefully this gave you a chance to feel like you didn't really miss the class. All right, so have a good weekend, and I will see you next week.